So hello, this is Bob from Test Equipment Chronicles with Bob. And we got something very interesting to do today. And the challenge here is to see if you're smarter than an AI. So I'm going to be using ChatGPT 5.2. And what we're going to be discussing here is a series of pictures. I have a PowerPoint presentation I have not seen before. It has pictures that I've taken over the decades. I used them at the college. And what I would do is I would bring these up so the students could view them, and then they had to identify the component. We made it kind of fun where the student could actually win some prizes. I had donations from different companies and so on, so it was actually kind of a big deal. But the students had to be able to go in, and I would describe a component that was in the image, and then they had to, of course, put their hand up and choose the component. They were pretty accurate with this. It was actually pretty good. So this was just a random selection of pictures. It was loaded into ChatGPT as a PowerPoint, and then I'm viewing it as a PowerPoint also. So other than the first slide, I have not seen these pictures in an awful long time. So I'm going to go ahead and I'll be describing to ChatGPT what exactly the image is. It has been uploaded so to know by slide number what's going on. So let's go get this thing started. So ChatGPT, I have a question for you here. The first image is in the center of the image, slightly above. There is a rubber hose coming in from the left-hand side, a bent steel pipe, and then there's a device, a little metal device that's in between. Can you tell me what that device is?
The device you're describing sounds like a check valve. In many emissions or air management systems, a check valve is placed in the line to ensure one-way flow, often allowing air or vacuum in one direction while preventing bad flow. Positioned between a steel pipe and a hose, it likely ensures proper directional flow in an air injection or similar system.
Okay, that is correct. That is an air injection system. Was used pretty extensively throughout that 60s, very late 60s, 70s, 80s, and somewhere into the 90s. Very commonplace. So yeah, that is a one-way check valve. Actually, problematic component. They would often leak upstream into the switching valve, or even into the air pump, causing some pretty expensive repairs. So that item you got. So let's go on to the next one. In the next slide, what we have is there's a series of hoses, one coming in from the top of the image, one coming in from the bottom, and in the center there's a cylindrical piece that connects the two hoses together. What is it? What is that item, and what is its purpose?
That cylindrical piece connecting the hoses is likely a vacuum delay valve. These valves are designed to delay the passage of vacuum for a set period of time. They're often used in emission systems like delaying EGR operation or delaying vacuum advance on the distributor. Its purpose is to ensure a timed vacuum response rather than immediate.
Okay, I hate to say it, but you got another one here. So that worked out pretty good. Yeah, actually, it was not a real problematic device. Everything vacuum controlled did have its issues. I didn't replace too many of them over the years because it was pretty reliable. Often used for anything from purge timing control to EGR to heat risers, anything where you needed to stop. Basically, it's a diode. It's a vacuum diode. In most cases, that configuration works just like that. Vacuum can flow in one direction, but will not flow back. So when the vacuum goes away in the engine, vacuum still is maintained in the line. We're going to move on to the next one. So next one's going to be slide number 3. In the center of the image, there's a large black canister of some type. I'm not sure what it's used for. So it's got two hoses going into it from the top, and one's got a little yellow connector that merges the two hoses together. So what is the first thing? What is that that apparatus? What is that item? And then what would that, with the yellow piece that connects the hoses together, what are them two items?
A large black canister is likely an evaporative emissions, EVAP charcoal canister. This stores fuel vapors from the gas tank to prevent them from escaping into the atmosphere. The small yellow piece connecting the hoses is likely a check valve or a restrictor related to the purge line. It ensures proper directional flow of vapors when the engine purges the canister, allowing vapors to flow to the engine but not back.
Yes, that is correct. You're correct on both items here. The second one, it's often a check valve, so that'd be, but it could be a controlled orifice. You had a look. There was a lookup table, so that's why that underhood decal was absolutely imperative, so you could know what these components were. Now, over time, you got pretty good at identifying what they were, and I was relatively good at that at the era. But them days have passed. Well, we're going to move on to the next slide. The next slide would be number 4. In the lower center of the image, there's a round can, and it's got 2 hoses coming out of the top of it. And then, respectively, there is a blue-colored connector or device. Tell me what that blue-colored device is. What do you think it is?
A round can with hoses sounds again like a variation of an EVAP or fuel-related component, possibly another part of the emission system. The blue-colored device is likely an electrical solenoid, often a purge or vent solenoid. These solenoids are electrically controlled valves that manage when the EVAP system opens or closes, like when to purge vapors into the engine.
That is correct. Actually, that was common. There was quite a mix of that era where we had a different variation of components that were used, both electrical and vacuum and any combination there above. Let's move on to the next one, and that would be number 5. Okay, this is kind of an odd looking one. What we have here is we have looks like a rubber elbow coming in from the left side, and an item we're in question here is in the very center of the image, and then there's a hose that sweeps down toward the bottom, and then it looks like there's a round cylindrical piece attached to it. What do you think that item could be?
This sounds like an EGR exhaust gas recirculation, backpressure transducer, or a similar EGR control device. In older systems, these units help modulate EGR flow based on backpressure. The round piece often is a diaphragm that senses exhaust pressure, controlling EGR accordingly.
That is correct. Actually, the electrical portion is just simply an enabling solenoid, so it doesn't work till that's turned on. But once that's energized, once the engine reaches a specific temperature, then that modulates, just like was stated there, the amount of EGR flow. Highly problematic item, very problematic. This was used on a Chrysler design here, and that was exhaust, or that would have been directly to the exhaust through a controlled orifice, but I won't go into the weeds on that one. And then that had a lot of water contamination. So water would get in there eventually. The really acidic water would corrode the inside. And the most often problem that you'd have is an overactive EGR valve. Vehicle prone to stalling, step in hesitation, and nobody would but think of this component. I don't know why, and I put a lot of these on vehicles that already had money shoveled underneath the hood, and to no avail, and then it ended up being this component. That's why understanding system knowledge and what the emissions, so that era from the late 70s through, I would say, about 2000, were just focused on all of these emission components that were needed, and they had their purpose, but they were problematic because the design was substandard in many cases. Okay, the next one we're going to talk about here is the very top of the image. We have 2 yellow, looks maybe like connectors, and the question I have is, what are they connected to, and what does it do?
Those yellow connectors are likely attached to fuel injectors, given 2 injectors side by side. This is probably a throttle-body injection TBI system. TBI was common in the 1980s and early 1990s, where injectors were mounted above the throttle plate, spraying fuel into the intake. These connectors provide the electrical signal to open the injectors, delivering fuel to the engine.
Do you recall what pressure most of these worked at? This was a General Motors, so what was the operating, what was the fuel pressure that was normally seen there?
General Motors throttle body injection systems typically operate at around 9 to 13 psi. It's a low pressure system compared to modern multi-port or direct injection, which are much higher.
What was the history of these as far as serviceability and reliability?
EBI systems were generally considered reliable and simpler than later multi-port systems. They had fewer injectors and operated at low pressure, so leaks or failures were less common. Serviceability was straightforward. Injectors were easy to access on top of the throttle body. However, they did have occasional issues with idle air control motors and throttle position sensors. But overall, they were a solid transition technology between carburetors and full multi-port injection.
That is correct. Actually, all the years, I think I've only changed a couple of them. Most of them were because of, I would say, backfire conditions where we had a throttle body fire. Other than that, they were incredibly reliable. The connectors were not so much. I managed putting on a number of connectors. On the same slide, we're going to move down a little bit and lower part of the image. And there is a device. It's black in color. It's got a hose that goes into the throttle body and then one coming over. Got an electrical connector to it. So it's just to the right of the I guess I'll say it, the thermostat housing. What is that item?
That black device with an electrical connector and vacuum hoses is likely a purge solenoid. For the evaporative emission system, the purge solenoid controls when stored fuel vapors in the charcoal canister are drawn into the engine to be burned. The solenoid is commanded electrically, opening or closing that vacuum path.
Okay, we'll move on to the next slide, number 7. That particular one in the center part of the image, sitting on top of the valve cover, that aluminum piece where the oil, there's an oil dipstick ahead of it, and then there is a filler cap. That device there has silver in color, comes out of the top of the valve cover, and then there's a line that runs over back to the engine, looks like the throttle body of the engine. What item is that?
That silver device on the valve cover with a line running to the throttle body is the PCV, positive crankcase ventilation valve. The PCV valve regulates the flow of blow-by gases from the crankcase into the intake. This helps reduce emissions and maintains crankcase pressure, ensuring any oil vapors are burned in the combustion process.
Okay, very good. Actually, that is correct. Highly problematic device. Actually, it had actually not the PCV itself is actually not problematic, but problematic if it wasn't replaced. Very inexpensive. Still used in one form or another today. Some are fully electronic control, but back in that era, they needed to be replaced. When the oil filter is changed and an air filter, that really was something that was very inexpensive, should have been changed, but it caused a lot of premature engine failures, where the engine would not be able to be evacuated of the waters and the acidic gases that get inside of there from the blow-by from combustion, and cause the engine to fail very prematurely. A lot of engines, the old classic engines, die before their time because of, at the time, the cost was about a $3 part. So I always thought that was kind of interesting. Every tune-up that I did would include a PCV valve, if applicable. And I put on a lot of them, and it wasn't that you made money, but I kept a lot of engines going that maybe under other circumstances would not have. Okay, we moved on to the next slide, and that is number 8. That one happened to be probably out of one of my training PowerPoints there. And in that particular case, there's an arrow in the image, and that's going down to a connector. And it looks like there's multiple wires in that connector. Tell me what that connector is hooked to, and then if it's got multiple wires, what does that do above and beyond if it just had a single wire?
That connector is likely for an oxygen O2 sensor. In older systems, a single wire O2 sensor only provided the signal. With multiple wires, you have a heated O2 sensor, commonly 3 or 4 wires. The additional wires power a heating element that brings the sensor to operating temperature more quickly, allowing it to provide accurate readings sooner. This improves emissions control, especially during cold starts.
Okay, you got that one correct. Let's move on to the next slide here. We're going to move on to slide number 9. In slide number 9, looking right at the center of the image, we have an opening, looks like on the side of the air box. And inside of there's some kind of, looks like possibly a flapper door. And what is that item and how does it work?
That opening in the airbox with a flapper door is part of a warm air intake system. The flapper door controls whether the engine draws air from a hot source like around the exhaust manifold, or from cold outside air. When the engine is cold, it pulls warm air to fuel vaporization as the engine warms up. The door switches to draw cooler outside air. This improves drivability and reduces carburetor icing in older systems.
That is correct. That item was a very common fail item, and I would always say that was probably the most overlooked of all things. I would technically say throughout the 70s, 80s, 90s, I guess would brag here a little bit, I made a small fortune of just simply fixing that. Can't tell you how many carburetors and even early throttle body injectors had been serviced, replaced, rebuilt, whatever the situation was. And it often made the vehicle maybe a little better, maybe a little worse, depending on what the air-fuel ratio was set after the rebuild. But most importantly, it was causing this carburetor icing under certain weather conditions. Not as prone in the southern states, but in the northern states, especially at transition time, when you would be getting into the cold weather, typically heading toward frost time. So you'd be looking mid 30s Fahrenheit. It was highly problematic. I remember vehicles that were predictable. You could drive them so many blocks, stop at an intersection, it would stall every time. And it was simply because it was getting cold outside, damp air, and that was simply icing across the throttle plate or around the throttle plate, blocking off the ports in the carburetor in that particular case, so it basically shut off the fuel. Vehicle would stall, heat from the motor would come up and melt the ice, and away you would go. And it could be repeatable as can be. And I remember a lot of this, so especially a lot of the sports cars, the ones I'm very, very familiar with, it had to be taken off, heaven forbid. Well, if you put on a big, like, gas toilet Holly, often you got to round it because there was so much fuel it would wash away the ice, and most times you didn't have a problem. But if you had a leaner configuration and just wanted to put on a fancy air cleaner without the warmer intake, or didn't want to replace that flex hose that's just below it, you had problems. And said it was an error because and we didn't have the trouble codes. Remember, there was no trouble codes for this. You had to do it on purely drivability, and you had to duplicate the situation. I would often go off how the customer explained it to me, and then made sure I went through a testing sequence. And this often just simply was discovered in the testing process. Okay, let's move on to slide number 10. Okay, slide number 10, you can see there is a belt-driven device, then like a silver assembly, and then a couple hoses that are attached to some apparatus at the back. What is that silver item with the belt on it, and then what are the components on the back?
The silver belt-driven device is an air pump, also known as a smog pop. It injects air into the exhaust stream to help reduce emissions. The hoses at the back are likely connected to diverter or check valves. These valves control where the air is routed, either to the exhaust manifold or downstream to the catalytic converter. It ensures proper air injection depending on conditions for more complete combustion of emissions.
Okay, very good. We got that. Let's move on to slide number 11. Okay, in slide number 11, we have a large black device that's in the center of the image, and then coming off of that, there's 3 hoses. And then there's a smaller hose on the bottom. What is that item, and what does it do?
A large black device with multiple hoses is likely an air management valve, part of the air injection smog system. It directs the airflow from the air pump. The hoses route air either to the exhaust manifold for cold starts or downstream to the catalytic converter. The smaller hose may be a vacuum line that helps control the valve's operation, ensuring air is sent where needed based on conditions.
Okay, you hit that one out of the ballpark, right on the money. We'll move on to the next slide. That would be number 12. Okay, looking down from the top, we have I'll even give you this one here. This is a carburetor sitting down there, but I got two other questions. To the right side of the image, there's a green connector that's coming out, and then there's a device in more the top of the image that's kind of grayish in color, and it kind of looks a little bit like a hat. So I would like to know in order here, what is that green connector, and then what is that item that has the hose coming out of it that has more of a hat configuration?
The green connector on the side is for a mixture control solenoid. In feedback carburetors, this solenoid adjusted the air-fuel ratio based on inputs like the oxygen sensor. The top hat-like component with the hose is the choke pull-off. It uses vacuum to open the choke slightly after startup, ensuring the engine doesn't stay too rich for too long. Both work together for cold starts and precise mixture control.
You got that one half of the question wrong. The top one is actually simply an EGR valve. And with the hose coming in, be the vacuum control for the EGR valve. So you've got that one. Without getting too technical, there's actually a small device that's just about off the image there. And what is that? There's kind of a little rusty just above the EGR valve with the vacuum hose going into. You have any idea what that might be?
Just above the EGR valve with a vacuum hose, that's likely a thermal vacuum switch. These switches are often threaded into coolant passages. They allow vacuum to flow, or not, based on engine temperature. When cold, it might block vacuum to the EGR. Once warmed up, it opens, allowing the EGR system to operate only at the proper temperature.
No, actually, no. That's more of a vacuum bleed or vacuum delay valve. So what it does is when vacuum is applied, it would allow vacuum to bleed off at a certain rate to get smooth transition into the EGR. Then we're going to talk about a couple more things. So we've got this carburetor image there. On the lower part of the image, hooked to the front of the carburetor, there is a connector going into the top of the carburetor with two wires coming out of it. Looks like a weather pack style connector. What is that component that it's hooked to?
That connector on the front of the carburetor with two wires is for the throttle position sensor. In later feedback carburetor systems, a TPS was used to inform the engine control unit of throttle angle. This helped the ECU adjust mixture or timing based on load and driver demand, an early step toward electronic engine management.
Okay, you got that one completely wrong. That's a mixture control solenoid connector. Can you describe on this image where the actual throttle positioning sensor wiring is coming in? It's a little hard to see, but it's very clear if you describe specifically where it's located.
Throttle position sensor wiring on a feedback carburetor typically comes from the side, near the throttle shaft. You'd usually see a harness or wires coming off the side of the carburetor, around the throttle linkage area. It won't be on top. Instead, you'll see it aligned with the throttle plate, sensing its rotation. In short, it's on the side, tracking throttle movement directly.
Actually, in that particular case, the answer is no. You were thinking of a little bit later models. Upper on the right hand side, just almost next to, but just above the green connector, is a kind of a tan colored piece that's going into the side of the carburetor. That is where our throttle positioning sensor is located, because that is actually controlled by some, I guess we'd say, some linkage inside of the carburetor. So unfortunately, you were wrong on that one. You had mentioned before about choke pull-offs. So look at the image and give me a description here of if there is any choke pull-offs on this carburetor, and then where they would be located.
In this type of carburetor, a choke pull-off is usually a small round or oval vacuum diaphragm. You typically see it on the top or side of the carburetor near the choke linkage. It often has a small rack connecting to the choke plate, if you don't see a separate vacuum diaphragm near the choke. This model might rely more on an electric or mechanical choke without a prominent external pull-off diaphragm. So if absent, it could be internally integrated or purely electric.
Okay, well, you didn't quite answer my question, but we'll move on. The very bottom of the image, to the right and to the left of the carburetor, we see a primary and secondary choke pull-off. Another money-making item. Boy, they failed like they were going out of style. I would tell you put on, and this would normally cause a condition when you started the vehicle up where the vehicle would, we call it blubber. In other words, it would sit there and smoke and choke, and you often realize that you rev it up to try to clear it out. And then once the engine warmed up enough where the choke could release, then it was fine. But the diaphragm didn't have, the diaphragm would rupture and not apply enough force or any force to the choke plate, causing this problem. When they were bad, they would often, ultimately fill the crankcase with gasoline over time, follow up the spark plugs that they would come out just black in color or even dripping with fuel. Again, another item. They were a little more pricey. I guess we'd say pricey relative at the time. $15 and maybe $35. Put hundreds and hundreds of them on. And again, I would say couldn't get over how some guys would just simply miss this. I seen carburetors that were overhauled and never a choke pull-off put on there. You charge the customer for a carburetor overhaul, but never actually. If you knew enough to overhaul a carburetor, you think you know enough. But anyways, a little rant here. But it's something I'd seen on too regular a basis back in. Again, I'm dating myself, so we're talking 70s, 80s, 90s, when that was very common. And of course, the choke pull-offs were used way back in the 60s. I think in the 50s. So it should have been an unknown item. So enough of my rant. Let's move on to slide number 13. Now we're going to move ahead. There's a couple here. I want to go to slide 14. In slide 14, looking at the image, we have a connector there, center of the image. What is that connector from, and what does it do?
That connector looks like a diagnostic connector from the OBD1 era, likely from a GM or similar manufacturer. It was used to connect a scan tool or jumper to retrieve trouble codes. By shorting specific terminals, the system would flash codes on the dash or provide data to a scan tool. It predates OBD2 and allowed technicians to read early electronic engine control data.
Well, you're correct to some degree, but it is from a Chrysler vehicle, and that one is intended to run a scan tool in. You could do a lot of controls, fuel pump, auto shutdown relay. There was a number of things that we're able to do, and scan data, depending on the era. Chrysler kept that particular connector. There was a couple others, but predominantly kept that one from real early 80s all the way up to when we switched over to OBD2, and that would have been that 94 to 96 time period. That's where your scan tool was hooked in, and I always said it was a hunting expedition to try to find where that connector was located. Now, granted, we had call-outs and so on, but I'm telling you, techs would work on them. They get stuff down below. Sometimes the books were wrong, but when you did find it, you got some limited. It would be a joke today what the amount of data, but we didn't have as many systems. So I would say on par, everything was about equal. Very limited amount of data coming to you, but very limited on the amount of systems. So it all worked out. But anyways, yeah, this was diagnostic connector used on Chrysler. Let's move on to the next one. This is my younger hands here, back in quite some time ago. Looking at a connector, it looks like a little house. What vehicle is that on, and what does it do?
That L-shaped connector is from a Ford vehicle. It's part of Ford's EEC4 system used throughout the 1980s and early 1990s. It served as a diagnostic port. Using a scan tool or even a jumper, you could retrieve flash codes. It was key for checking engine faults before OBD2.
That is correct. Got that one. Also had a couple other little features. You could backfeed it. I had even made up a device for that. So you could run the fuel pump right through that connector. There was also, that was the gray ones were the diagnostic connector for engine control, but there was also some other colored ones on there. I think it was red for ABS, and they had ride control and so on. So you'd see the same connector, but for very specialized applications. So, yep, you got that one. Let's move on to the next slide. That would be number 16. There's a call out on here, and you see A and B. First off, what is that connector for? And then what was the call out for A and B?
That connector is a GM OBD1 ALDL, assembly line diagnostic link connector. It was used for pulling codes. A and B were terminals you could jumper to make the check engine light flash out store codes. It allowed basic diagnostics, no live data, but you count flashes to read trouble codes directly from the dash light.
Okay, very good. Actually, you hit that one right on the head. Let's see. What do we got here? It's got a red connector, or part of it's red connector to a gray. Some wires going into it, black in color. It's right in the center, and it's got some hoses coming out of it. What do you think that could be?
That black component with a red connector and hoses is likely an EGR, exhaust gas recirculation solenoid. The EGR solenoid controls vacuum to the EGR valve. When commanded by the engine control unit, it opens or closes to allow EGR operation. This reduces NOx emissions by recirculating some exhaust gases back into the intake.
That could be correct, since it's been so long since I've taken this picture. We've been decades ago. I would have to say that might be purge. The look at the diameter, the hoses are a little bit larger, and without being able to see where they go, we're taking a guess. But yeah, the EGR control solenoid and the purge control solenoid often look very similar. I'm going to take my bet, and there's no guarantee on it. Tell me in the comments. It looks like a purge control solenoid. Okay, let's move on to slide number 18. And then we could see we have a heater hose coming through here. And then ahead of it is like a cylindrical disc. And then also to the right of it is another component there, kind of like a chamber with a lever coming out of it. So what is the cylindrical piece that's black in color, and then to the right of it, I guess we'd say kind of more of a gray colored piece. What are them two pieces?
The black cylindrical piece in line with the heater hose is the choke pull-out. It uses vacuum to gradually open the choke on cold starts. The gray chamber with a lever is the mechanical or thermostatic choke housing itself. Inside, a bimetallic coil or thermostat opens the choke as the engine warms. Together they regulate airflow and mixture during warm-up.
Well, I think you got it backwards. You didn't do too bad, but the part that's right by the heater hose, the cylindrical part, is actually the choke coil, and truly is a bimetal coil that's located in, hooks to the linkage going up to the choke plate on the carburetor. The item that I was referring to the right of it is the choke pull-off, the ones that I had made reference to earlier that are very highly problematic. Looking at this image right now, can you tell if this engine is running or not running based on the image itself?
The image alone is hard to definitively tell if the engine is running. Typically, if the choke pull-off rod is retracted and the choke plate is partially open, it suggests the engine has vacuum and may be running or was recently, but without a direct view of moving components like belts or sound. It's not absolute. Visual cues alone can't confirm it 100%.
Well, visual cue on my perspectives, you can see the wear mark on the side of the linkage coming out of the choke pull-off, indicating that it's at rest right now. It's not vacuum is not applied, so we're assuming the engine's not running. It could also be running and the vacuum supply is bad and or the diaphragm. So that was an open-ended question, but the calibrated eye would be able to look and see that choke pull-off is hanging out there, not retracted back. And so if I had this, I was underneath the hood of this vehicle and it was idling and I saw that, I would immediately take action of looking at what was wrong with the choke pull-off system. Now, on the same image, going up to the upper right-hand corner, there's a two-wire connector going into a black, two wires going into a black connector that goes into the top of the carburetor. Do you have any idea what that connector is going to?
The black connector on top of the carburetor with two wires is most likely for the bowl vent solenoid. In electronic feedback carburetors, this solenoid controlled the venting of the float bowl. When the engine was off, it could close the vent to prevent vapor escape. When running it open to allow normal bowl venting. It was part of the evaporative emission strategy of that era.
Well, you're actually wrong, but that was actually you're off by some years. That system, which you're describing there, was used. And actually, it was used even into the feedback carburetor time, but predominantly covered in the late '60s, real early '70s. I would say actually through the '70s, where you didn't have feedback carburetors at that era. But yeah, the bowl vent solenoid to control that was real early evaporative emission system. So good point. That is not. That is the mixer control solenoid wires. Very similar to what we had discussed earlier. So we had that top view earlier. Now we have a side view of the same thing. That mixer control solenoid worked at, hey, got a question for you. The mixer control solenoid on a General Motors vehicle, what frequency, how many hertz does it pulse the mixer control solenoid at? Do you know?
In GM's feedback carburetors, the mixture control solenoid typically pulsed at around 10 Hz. This 10 times per second frequency allowed fine control of the air-fuel mixture, adjusting duty cycle to meet emissions and performance targets.
Okay, so now we know that it was at 10 hertz. That's 100% correct. Do we know if and I had the earlier picture showed the green connector, that we would look at the dwell reading, excuse me, pardon me, and dwell reading or duty cycle. I'm going to go with duty cycle because techs out there are going to understand it a little bit better. The duty cycle, if I was going down the road and I had a meter on it and I saw a 50% duty cycle and I was staying constant at my 10 hertz and the little carburetor just rattling away, what would that indicate? If I'm driving down, say 30 miles an hour, meters hooked to it, everything just at a cruise, not a hard acceleration. If I had a 50% duty cycle, what would that be?
.50% duty cycle on that mixture control solenoid means the system is balanced. The ECM is not adding more or less fuel, it's right at stoichiometry, ideal air-fuel ratio. In other words, it's neither rich nor lean, just right for cruising.
So that era of vehicles, that is 100% correct. What air-fuel ratio was we trying to target on this vehicle, and how do we discern that? So what air-fuel ratio we're trying to achieve we're going to go in U.S. standard, not Lambda. And then with that, how is it viewed or how is it determined?
The target air-fuel ratio was about 14.7 to 1, the stoichiometric ratio for gasoline. This was determined by the oxygen sensor. The O2 sensor's voltage tells the ECM if the mixture is rich or lean. The ECM adjusts the duty cycle to keep the mixture swinging slightly around 14.7 to 1. Neither too rich nor too lean.
You know, being a past educator, a past researcher, I have probably said 14.7 to 1 air-fuel ratio at least 10,000 times in my life, maybe better. So I just find it kind of interesting. We've always used that. Unless and of course, the newer vehicles are working on Euro vehicles, and then we're in Lambda. I always thought that it was like talking a little bit different language going from U.S. standard over to metric. But anyways, we got by. Interesting. Thanks for the feedback there. Okay, there is an item right in the center, kind of got a gray cover to it, right in the center of the image. You actually can see our zip tie there. holding on a couple vacuum hoses. What item is that, and how does it work? Well, it looks like ChatGPT has given up the ghost here. So we'll go ahead and we'll talk about this last item. This last item here that we're going to look at, that is a thermal switch. These were used in that, again, back in that era. They were actually used from, I think, the late 50s all the way up somewhere into the 90s. I don't remember seeing anything after that. But what they did is they would actually thread it into the intake manifold and looking at it from the coolant temperature. So when the engine would reach a specific temperature, it would actually allow vacuum to flow or shut it off. There was a wax pellet that was located inside of the thermal vacuum switch, and it would either be, as it expanded out from the heat, it would either open or close a passage. These were crazy to diagnose. You had something that, say, an engine for EGR, an engine that would start to knock and then the knock would go away. And that would be in a thermal vacuum switch that was coming on too late, giving you EGR valve way beyond the point where the engine had already warmed up and needed the EGR. That was the era that we dealt with it. Well, anyways, so the whole idea behind this exercise was to show how ChatGPT is out there and the AI systems can identify these components. I had a lot of training went in place, and I don't have an opinion on this. I just wanted to demonstrate that that tool is very good at doing this. And remember, we're on a lot of the older systems, and as you get into the newer ones, I've done this on new, and it's relatively accurate. But like any piece of information you get, you can't trust it. You've seen it. It didn't miss too many, but when it missed it by a country mile. So if you were trying to make a decision on going forward with a diagnosis without looking it up and having some level of verification, it is able to look at all these images very clearly and extract off. There was nothing played here. I literally have a PowerPoint, and you've been seeing all the images as we moved along, and that PowerPoint was loaded into ChatGPT, and then I got the dialogue going. So that was the extent of what took place. So I thought it would be kind of interesting. I use this tool all the time, and I look at it as a tool. Nothing fancy, nothing special. It's just another tool in my tool arsenal. But it is a good tool, but I would not call it a trustworthy tool. It's one of those tools. We all got them, and it's like looking at scan data. Believe but verify. This information, believe but verify. So it does work good, as you can see. It does get a little confused. Now remember, the older vehicles or something is not well documented, it will not be able to figure it out on its own. It has reasoning, but not the reasoning we think, because remember, it is a large language model and is only looking at past history. Think about library. This is a massive library beyond our comprehension. But nonetheless, if it wasn't documented, you can do something kind of fun here. If you are using AI, go back and look at some of the older vehicles, Z28 Camaro with LT1, and it is amazing there because there's so much documentation in that era. Where the documentation does not reside is in these obscure areas, emissions of that area. There wasn't much of that ever digitized. As we're getting into the new one, endless amount of scan data and waveforms and so on. Well, anyways, I'm going to conclude this, but if you enjoyed this and you got something out of it, I would be more than happy to do this again. Just please write in the comments that if this did interest you and it's something you'd like to see again. Well, I thank you and have a most wonderful day.